Hi, okay, welcome to the next session of the grade 4 course. We're doing our normal recap. So obviously I'd like you to hit that pause button and have a really good go at those questions. Feel free to look things up. Remember, it isn't a test. I want you to just keep going over these same things so that they start to become more natural in their response and your confidence just generally grows. That's what we're aiming for. So hit play when you're ready. Okay, so there's the answers. Just hit pause, press play once you're all done, and then we'll get started. So we're carrying on with our topic of percentages, and we're going to be looking at simple and compound interest today. Mainly compound. Simple is simple. I want to explain the difference between the two, so that you are aware of that and you are able to use that as part of your knowledge when it comes to problem solving. But we won't be sticking with the simple particularly in this session. It'll probably crop up in those recaps and consolidations just to make sure that you are remembering the detail about simple interest. So let's have a little look at what I'm talking about. So I'm going to use a very simple example. I'm going to say that I invest £60 at 10% interest. We'll write interest as well, 10% interest. And we're going to do that over 3 years. Okay, so that's my basic that's going to happen. If I invest that in a bank that's going to offer me simple interest, what that means is the bank is going to look at what I'm investing, £60. It's going to work out 10% of that 60, which is 6. And it's just going to pay me that for every year I keep the money in the account. So if I keep it in there for 3 years, they're going to pay me 3 lots of £6, and I will earn £18 interest with that bank. Now, something that I need to say very quickly is you would never earn these type of interest rates in a bank. So don't think, oh, that's worth investing £60 to get 18 back. Doesn't quite work with those numbers. It's 10%, so we can see what's going on. Okay, compound interest works in a slightly different way. So if I've got a bank offering me compound interest, it's going to do the same thing in year 1. So in year 1, it's going to give me 10% of my 60, which is £6, okay? And that means that I've got a balance of £66 in my account. So that when it comes to year 2, this bank is going to actually work out 10% of my balance of my £66. And then they would add that into my account at the end of year 2. So I've now got £72.60. At the end of year 3, they're going to do the same and use my balance, my current balance, to work out what my interest is going to be, which is going to be £7.26. And when you add that onto what's already in the bank, I've now got £79.86. If I added on the £18 that I earned in my simple interest account, I got £78 in total. So you can see the difference when you are adding interest to the balance that you're earning every year. That is growing your kind of investment even more. So compound is generally well worth going for, not simple. But again, if you've got a problem solve, you've got to look at what the two are offering, because if the interest rates are different, then obviously your yield, the money that you're going to get back, will be different. So you need to check both to decide which is actually going to give you that better value. So those are the differences. Now let's just concentrate on compound for one moment. If we think about the question that we were given, when you invest money in an account to earn you interest, then it's giving you extra additional money. So it's an increase question. So that interest there is telling me it's an increase. And this 10% here is giving me 2 ticks. And a 2-tick question is original times multiplier equals results. We obviously know that by now. So we do use this formula, but what we do is we put an add-on. I don't want to do this question 3 times over. I want to be able to do it once, efficiently and quickly. These are on calculator papers, so I don't have to worry about the actual doing of the maths. I have to worry about the setting up of the maths, knowing what it is I've got to put in that calculator in the first place. So to save me doing it in year 1 and then doing it again in year 2 and then doing it again in year 3, imagine if the question was 5 years. Oh, no thanks. I don't want to do that much work. So the add-on, where the calculator will automatically do this for us, is over the multiplier, and it's a power. It is the power of whatever the time is in the question. Now, in this question, it's 3 years, but it could have been 3 days, it could have been 7 days, it could have been 2 weeks. You know, as long as it's a period of time that I can express numerically as a power, then it's going to work. So I could have put £60 times the multiplier. Now, a 10% increase is going to be a 1.1. You could include the 0 if you want. That's my multiplier over 3 years. And when you put that into the calculator, you will get the same result. So that's our shortcut method. We're going to use the original times multiplier because it's a 2-tick question, but we have the add-on of time, that this is repeating in a cycle. Okay, so let's do a couple of questions so that we can get into the swing of this. All right, so I invest £2,000 over 3 years at 7% compound. And it's important because it will be in the question. They will have to say that word compound for you to know it is the multiplier with a power. All right, so they will use that language, and it's the trigger there, or just the period of time. But if you're not careful, you might end up doing it for simple. So it really is compound, it's going to tell you. So I invest £2,000 over 3 years at 7% compound interest. How much do I have at the end of that period? So hit pause and press play. See if you have managed to remember enough to get it right first time. Okay, so it's the original 2,000 times the multiplier 1.07 to the power 3. Pop that in my calculator and I get 2450.09. So pop that pound sign in front, and that is my answer. So hopefully that went well. Feel free, and I would encourage it, and I will do it actually on the next one. Original times multiplier to the power of time equals result. That needs to be written out if you are going to get that brain to start to build a memory for you to be able to recall against. If you never write it down, why are you going to remember it? Okay. All right, let's do another one. So I invest £7,500 over 4 years at 3.2% compound interest. Okay, and again, the question is, how much will I have at the end of that 4-year period? So hit the pause button and have a go at that question. Okay, so original times multiplier equals result. My period of time is in the question. So the original is 7,500. Okay, 100 plus 3.2 is 103.2. So 1.032 is your multiplier with the power 4 for the 4 years. And that is going to give you 8507.0709 when you put it in the calculator. So my final answer is 8507.07. Must make sure I give my answer as money. Okay. Let's do another. I buy a car for 12,000. It loses value at a rate of 6% each year. What is the car worth after 5 years? Okay, so I buy a car for 12,000. It loses value at a rate of 6%. What's it going to be worth after 5 years? Hit pause and press play when you are ready to see if you've got it right. Okay, this question. Now this is a decrease, it's losing. So my multiplier is going to be the 100 take away. Okay, so I've got original times multiplier equals results, and then I've got a period of 5 years, so I've got my add-on. My original is 12,000. 100 take 6 is 94, so 0.94 is my multiplier with that power of 5 for time. And that gives me 8806.8482, which is 8,806.85. So even if it's a decrease over time, it's done in exactly the same way. A multiplier is a multiplier, never going to have a different way of doing a multiplier. So we should be really good at that by now. Okay, great. So we are going to do one more, and then I'm going to leave you with some practice. So I'm going to say Harry invests £4,500 at a compound interest rate of 4% at the end of n years. He has 5,264.36. Find the value of n. Okay, now that has come from an exam, a past previous exam. So I don't want to just show you, I want you to have a think about it. We've got a level of knowledge that we have been using, and it's that same knowledge that's going to help me solve this question, although the question is slightly different. So hit pause, just go with your ideas and see what happens, and then press play when you're ready. Okay, I've got my calculator at the ready for this one. So I know that this is interest. Okay, I've got a percent. I know it's original times multiplier equals result. I know there's a period of years. I just don't know how many there are. So my add-on is there. And what I'm going to end up producing is 4,500 times 1.04, that's the multiplier, an increase of 4%, with the n, the number of years. I don't know what it is. It's n in the question. So it's going to be n in my formula. And I know that that's got to equal 5264.36. So what we do here is a trial and improvement method. So I am going to guess a year, literally. I'm just going to make up what I think the year might be. Now, it's increased at a reasonable rate. So I'm going to go for 3 years and see what it gives me. So I'm going to do this into my calculator. And it's given me 5061.888. So that's too low. So now I'm going to improve on my guess and say I think it might be 4. So I'm going to be putting in the exact same thing, just with power 4 instead. And happy days. That gives me 363, on and on it goes. So n must be 4 years. Okay, so I wasn't doing anything different as far as my formula and my approach, but I can't rearrange to get n on its own. I can't do it that way, you know, by hopping. So I've got to do trial and improvement instead. So hopefully that was something that you thought through and thought you could try for yourself. But that would be the approach. Right, these are your questions. So I'm going to do the norms, scroll through them slowly so that you can see them all, and then bring up the answers. So best of luck with this, and I will see you next session. Okay, so the insect population where you haven't been given a starting number, you can literally use any value. I chose 50 because it came to me. It's a nice round, easy number. I can work with that fairly easily. So, but it didn't have to be 50. 100's another really good one to use. So if you weren't sure about how to do that one, that is a way of doing it, not the only way. Okay.